Good morning. So our topic for week 1 is all about random variable and probability distribution. So what do we mean by random variable? A random variable is a variable whose possible values are numerical outcomes of a random phenomenon or experiment. So there are two types of random variables. First one is the discrete random variable and the second one is the continuous random variable. So first, let us now go to discrete random variable. So a discrete random variable is a variable which can take only a finite number of distinct values, meaning it represents count data. So it means that it is countable. When a variable is countable, it is a discrete random variable. So here are some examples of discrete random variable. The first one is the number of students in a classroom. You can count the number of students in a classroom. If you can count it, therefore it is discrete random variable. Second one is the Friday night attendance at the cinema. Number of storms per year in the Philippines and a price of a pen. So as you notice, all these examples are countable, meaning they are under a discrete random variable. So let us now go to the second type of random variable, the continuous random variable. So a continuous random variable is a variable which takes an infinite number of possible values on a continuous scale. So it represents a measured data, meaning it is measurable. So these are some examples of continuous random variable. First one is the length of time it takes to go from Pampanga to Manila via bus. Second one is the speed of ball when spiking in volleyball. Third one is the weight of an elephant. Lastly, the height of a grade 6 pupil. So as you notice, the length, speed, weight, and height are all measurable. Therefore, all these examples are under continuous random variable. So before we proceed to activity B, let us first summarize the difference between a discrete random variable and a continuous random variable. A discrete random variable, just remember, a discrete random variable is countable, while a continuous random variable is measurable. So in a discrete random variable, you can see the word number of because that number of is a sign or a clue that that specific variable is countable. While a continuous random variable, you can see a clue like length of, width of, height of, speed of. If you see those words, it is automatically continuous because meaning they are measurable. So now let us proceed to activity B. Let us determine whether the given variable is discrete or continuous. So number 1, strength of an earthquake recorded by Phoebox. Is it discrete or continuous? So the answer is continuous. Can you count the strength of an earthquake? No. Can you measure the strength of an earthquake? Yes, that's why it is continuous. And because of the keyword strength, that's why we can say that it is a continuous random variable. Number 2, monthly expenses of a family. Is it continuous or discrete? So the answer is discrete. Why discrete? Because of the word expenses. Um, in our previous slides, I gave you an example of prices of a pen or price of a pen, and it is under discrete. That's why when you see prices or expenses, it is automatically discrete random variable. How about this? Speed of a bicycle during a race. Is it continuous or discrete? So the answer is continuous. Why continuous? Because of the word speed, right? Number of patients with COVID-19 in a hospital. Is it discrete or continuous? So the answer is discrete. Why discrete? Because of the word or the keyword number of. When you see the word number of, thematically, it is a discrete random variable. Number 5, names of the months in a year. Is it discrete or continuous? So the answer is neither. It is neither discrete nor continuous because you can neither measure it nor count the names of the months in a year. But when we say the number of months in a year, it is a discrete random variables because we're dealing with the number of or the keyword number of. Number of enrolled grade 11 students in a school. Is it discrete or continuous? The answer is discrete. Number 7, cube root of 3. Is it discrete or continuous? So the answer is not a random variable. So back to our previous slide, what is the meaning of random variable? So a random variable is a numerical outcome of a phenomenon or experiment. In this case, cube root of 3 is not a numerical outcome of phenomenon or experiment. Rather, it is a constant. Final grade in mathematics then. Is it discrete or continuous? So the answer is discrete because final grade is countable. Last number, height of grade 11 students. Is it discrete or continuous? So the answer is continuous because of the word height. So let us now proceed to probability distribution of a discrete random variable. By definition, probability distribution, or also known as probability mass function, is a table which consists of values a random and the corresponding probabilities of the values. Second one is the histogram. Histogram is a graphical representation of the distribution of numerical data with possible values on the x-axis and probabilities on the y-axis. Histogram will not be discussed further. So there are two properties of a probability distribution that needs to be satisfied in order for it to be called probability distribution. The first one is that the probability of each value of a random variable must be between or equal to 0 and 1. In other words, p of x should be less than or equal to 1 but greater than or equal to 0. The second property is that the sum of the probabilities of all values of the random variable must be equal to 1, or the summation of p of x is equal to 1, wherein p of x is the value of each probability. So before we proceed, let us first have a short activity. So we determine whether the distribution represents a probability distribution or not. So the first one, the table, x is equal to 1, its probability value is 1/3. X is equal to 5, its probability value is 1/3. X is equal to 8, 7, and 9, its probability value are all 1/3. Does it satisfy the first property wherein p of x should be between or equal to 0 and 1? Yes, so it satisfies the first property. How about the second property, which is the summation of p of x? The summation of p of x should be equal to 1 to satisfy the second property. Is it equal to 1? So when you add 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3, it is equal to 5/3. Therefore, it does not satisfy the second property. Is it probability? The distribution represents probability distribution or not? The answer is not. So the second problem or Number 2, P of 1 is equal to 0.20, P of 2 is equal to 0.50, P of 3 is equal to 0.3. Where when you draw a table that is x is equal to 1, where therefore the probability value is 0.20. X is equal to 2, P of x is 0.5. X is equal to 3, P of x is 0.3. Does it satisfy the first condition wherein each value should be between or equal to 0 and 1? Yes. How about the second property, wherein the summation of P of x should be equal to 1? So, P of x is equal to 0.20 plus 0.50 plus 0.30. And when you add them, it is equal to 1. Therefore, the distribution represents or it is a probability distribution. So, last number, P of x is equal to x over 10 for x is equal to 1, 2, 3, and 4. So, when we construct the table, you write the value of x, then 1, 2, 3, 4, and P of x, where P of x is equal to x over 10, where x is equal to the value of x. So, we just replace the value of x into the x here, the numerator. So, if x is equal to 1, therefore, the probability value is 1 over 10. If x is equal to 2, the probability value is 2 over 10 or 1 over 5. If x is equal to 3, the probability value is 3 over 10. If x is equal to 4, the probability value is 4 over 10 or 2 over 5. So, does it satisfy the first condition wherein P of x should be between or equal to 0 and 1? So, yes, they are between 0 and 1. How about the second condition wherein the summation of P of x is equal to 1? So, P of x is equal to 1 over 10 plus 2 over 10 plus 3 over 10 plus 4 over 10. So, the answer is 10 over 10 or 1. So, therefore, it is a probability distribution. Now that we know on how to determine if the distribution is probability distribution, we proceed to the steps in constructing a probability distribution. So there are 5 steps. The first step is that you write all the possible outcomes of the experiment or phenomenon. Second step, determine the value of the random variable in each outcome. Third, you construct a table for the probability distribution. So you write the values of x without repetition. So no need to for repetition, and arrange them in ascending order. Number 4, write the corresponding frequency of each value. And lastly, write the probability of each value by dividing its corresponding frequency by the total frequency. So let us have some examples. So the first given is that the two bubble gum balls are drawn in succession without replacement from a box containing 3 black gum balls and 5 pink gum balls. Let x be the random variable representing the number of black gum balls. Make a probability distribution for the random variable x. So, constructing a discrete probability distribution, we just followed the 5 steps. So, here, it says here that there is a box and that box contains 3 black gumballs and 5 pink gumballs. Then, it also says here that there will be 2 bubblegum balls to be drawn in succession without replacement. And also, we make the probability distribution of random variable x where x represents the number of black gumballs. So we're getting the probability distribution or the discrete probability distribution of the black gumballs only. So let's proceed to first step or the step 1. Write all the possible outcomes. So we have a table here. On the left, we have the outcomes, and on the right are the value of x in each outcome, or the number of black balls, because we're getting the probability distribution of the black, only the black gumballs. Okay. So first, we determine the outcomes. On the first drawn of ball, or the ball 1, we can get black, and on the second drawn, on that box, which consists of 3 black gumballs and 5 pink gumballs, we can get another black. So how many blacks or black balls are there? So there are 2. How about on the second outcome? It can be on the first outcome, the first drawn, black, the second, pink. So how many black? 1. We're only counting the number of black balls here. So the third one, pink and black. First drawn is pink and the second is black. So how many black? 1 again. Lastly, it can be pink, pink. So how many black balls are there? So no black balls. Based on the table, the possible number of black gumballs were, when 2 gumballs are drawn in succession, are 0, 1, and 2. So according to the steps in constructing discrete distribution or probability distribution, we should arrange them in ascending order, and there should be no repetition. So let's proceed to step 3. Step 3, we construct a table for probability distribution. Write the values of x. So here is the table for probability distribution. So here is the value of x. What are the values of x? That is 0, 1, and 2, right? So we arrange them in ascending order. 0, 1, 2 pataas. So step 4, we're done there. So step 4, write the corresponding frequency of each value. Frequency means the number of times an event occurred. So ilang beses siya naging 0? So only 1 nung nag-pink-pink yung outcome. How about nung 1? How many frequency? So there are 2 nung black-pink and nung pink-black. How about nung dalawang beses lumitaw yung black? Ilang beses siya? So 1 lang. 1 time lang yon. 1. So we write the probability P of x of each value by dividing its corresponding frequency by the total frequency. So first, before proceeding to step 5, we should get the total frequency first. So here is the frequency. So what is the total frequency? It is 4. Total is 4. How about step 5? In step 5, all we have to do is divide the corresponding frequency by the total frequency. So the corresponding frequency here is 1 divided by 4, that is 1 over 4. 2 divided by 4, that is 2 over 4, or 1 half. 1 or 1 over 1 divided by 4, that is also 1 over 4. So last activity or last example. A magic ball shows a number from 1 to 4 when tossed in the air. So there is a magic ball with numbers 1 to 4 when tossing in the air. So construct a probability distribution of the sum of numbers when 2 magic balls are tossed. So in tossing 2 magic balls, we can get 1, 1. On the first magic ball, there is it could be number 1. The second magic ball, it could also be number 1. So that is 1, 1, and their sum is 2. On the second tossing of 2 magic balls, it can be 1 on the first magic ball. 2 on the second magic ball. So that is 1, 2 with sum of 3. Second, the third, 1, 3. So their sum is 4. Fourth, 1, 4. Their sum is 5. Okay, on the fifth one, the magic ball 1 we can, after tossing it, we can get 2. The magic ball 2, we can get 1. So 2, 1, that is 3. 2, 2, that is 4. 2, 3, that is 5. 2, 4, that is 6. So, nakakasunod ba? Next is 3, 1. Here, 3, 1. And their sum is 4. When you add them, that's 4. 3, 2, that is 5. 3, 3, that is 6. 3, 4, that is 7. 4, 1, that is 5. 4, 2, that is 6. 4, 3, that is 7. And 4, 4, lastly, 4, 4, that is 8. So, thus, the possible values of x, or the sum of the numbers when two magic balls are tossed, are, it can be 2, 3, 4, 5, 6, 7, and 8. Those are the possible sum of the two magic balls when tossed in the air. So, what step are we? We are on step 3, right? We determine the x. So, what are the x here? That is 2, 3, 4, 5, 6, 7, 8, right? So, we write 2, 3, 4, 5, 6, 7, 8. So, frequency. Step 4, frequency. How many times 2 occur? So, we count them. So, 1. Okay, 1 only. 1. How about 3? We count them. 1, 2, 2. How about 4? 1, 2, 3, 3. How about 5? How many times does 5 occur? 1, 2, 3, 4. So 4. How about 6? So 6. 1, 2, 3. 3 times. 7, 1, 2. Twice. How about 8? Once only. So, after getting the frequency, step 4, before proceeding to step 5, we should get the total frequency first. So, the total frequency is 16. That is 1 plus 2, 3, plus 3, that is 6, plus 4, that is 10, plus 3, that is 13, plus 2, that is 15. So, 15 plus 1, that is 16. So, the total frequency is 16. Now that we know the total frequency, we can proceed to step 5, which is dividing the frequency by the total frequency. So, the frequency in number 1 with the sum of 2 is, we divide 1 by the total frequency, which is 16. 1 divided by 16 is 1 over 16. How about 2 divided by 16? That is 2 over 16, 3 over 16, 4 over 16, 5 over, okay, 3 over 16, rather, then 2 over 16, and lastly, 1 over 16. So, did you understand the lesson? So, alam na this, sagutin na yung evaluation. So, here are some tips in answering the written work and performance task for week 1. So, ito yung sasagutin natin sa week 1, written work. Just determine if it is discrete or continuous. Write D if it is discrete and continuous, capital letter C. So, alam natin, kapag discrete siya, alam na natin, Discrete is countable while continuous is measurable. So, alam na natin na discuss ko na yung mga keywords para malaman kung continuous siya or discrete. So, pwedeng clue natin yun. Letter B, performance task. So, I sent a correction on your GC. Hopefully, nakita nyo yon. So, yun sa performance task naman natin, yun yung diniscuss ko na hanggang step 5. So, number 2, ayun, ganun din, step 5. Tapos may kalakip silang points when outcome with corresponding probability is complete and interpretation, that is 10 points. 9 points, outcome with corresponding probability, complete and correct, 9 points. So, wala siyang interpretation, 9 points lang. 7 points, 8 points pala, kapag complete outcome with corresponding responsibility. So, hindi naman nating sinabing correct, pero kompleto siya, 8 points na agad, di ba? Kapag yung outcome is complete, 7 points na. So, letter C, you determine whether the distribution represents a probability distribution or not. Explain your answer. It was already discussed in this video lesson. How to determine the probability distribution, if a distribution is probability distribution or not. There are two properties, right? The first property is P of X should be between or equal to 0 and 1. And the second property, the summation of P of X or the sum of all the possible values should be equal to 1. No more than 1 or less than 1. Hindi na pwede. So summation of P of X should only be equal to 1.